All right, so now let's solve example 3 here, which is a variation of example 3 in your book in section 5.1. It says here, solve the system of equations by graphing. All right, last time we had to do this, we graphed the two equations by finding the x and y intercepts for each equation. This time, I'm going to suggest we do it a different way, that we use the point-slope formula here to graph the equations. It has the advantage that, as we'll see in this example, of actually screening out special cases. Alright, so let's attack equation 1. Equation 1 is minus 3x plus 2y equals 4. And that's in standard form, so we'll have to reduce that to slope-intercept form. And we'll have to do the same thing with equation 2, which is up here. And that'll be 6x minus 4y equals 8. Alright. To get this into point-slope form, I got to get the x's on the other side. So I'm going to add 3x to both sides. That cancels. I end up with 2y equals 3x plus 4. Divide both sides by 2. 2 divided by 2 is 1. Oops, I missed. And I end up with y equals 3 halves x plus 4 divided by 2 is just 2. Alright, we're going to plot this using the point-slope formula here. So let's do that. Alright, we'll do this as a sketch. Instead of doing graph paper. Alright, what do we know? Well, we know first of all we start here. This is B. Alright, which is somewhere, this is the y-axis, this is the x-axis. This is somewhere on the y-axis. And specifically it's at the point 0, 2. Alright, we also know the slope. That's this guy here, m. M equals the change in y over the change in x. And that, in this case, is 3 halves. So, this is the change in x. So, if x is 0, I'm going to add 2 to get my new x, which is going to be 2. And this is the change in y. So, if y is 2, I'm going to add 3. And now 2 plus 3 is 5. So now I have the point 2, 5. Should be out here somewhere. 2, 5. Again, this is not drawn to scale. This is just to give us a rough sketch of what it would look like. So my line would look something like that. So it's upward sloping, which is what I expected with 3 halves x slope, positive slope. So now I want to do the same thing. I want to reduce this form to that form. So let's do that. We do that by getting rid of the 6x, subtracting 6x from both sides of the equation. That goes to 0 and disappears. This becomes minus 4y equals minus 6x plus 8. Divide both sides by minus 4. That cancels, and I get y equals minus 6 over minus 4x plus 8 over minus 4. Well, we can simplify that a little bit. Minus over minus is going to be plus. And if I take 4, that's going to be divided by 2 twice. 3 is going to be divided by 2. I'm sorry, 6 is going to be divided by 2 3 times. So this becomes 3 halves x plus, well, actually plus it's going to be a minus because of that minus there. So we make that a minus. 8 divided by 4 is 2. So I have y equals minus 3 halves x plus 2. We have a problem. What's our problem? The slope here, m1, is 3/2. The slope here is m2, also equals 3/2. If we were to plot it, here's B. So B would be down here somewhere at 0, -2, and it would have the same slope, so it would look something like that. All right, and these two lines are parallel. Lines are parallel, therefore no intersection. All right, because parallel lines never intersect, and that implies no solution. So there is no solution to this set of equations. In other words, there is no x and y that will satisfy both equations simultaneously. All right, you should try this from the book. Here's example 3 as it actually appears in the book, and that's on page what? Page 284. Page 284. Good luck. Bye now.